resolve whatever it is that way. Brad, you're on deck, presumably?
All right.
What's the duration you expect?
Maybe 25 minutes.
That'd be totally awesome.
All right. I almost pushed the button to stop recording.
All right.
The right button. Let's see.
Brad Nelson, astoundingly talented and productive guy. We'll talk on Forth synergy.
All right. Is that visible to everyone? And can you hear me?
I can see your slide and I can hear you.
All right. Let's do it. Today I'm going to talk about a problem that we sometimes have in the Forth community, that our preferred programming language tends to veer towards kind of lone wolf behavior. We don't often collaborate as much as we might, and I think there's a number of reasons for this. But really, what it comes down to is that while Forth is powerful and has abilities that are absent or sort of only partially present in other languages like compile time metaprogramming and the ability to sort of seamlessly embed a domain-specific language, and while it's also very succinct, that succinctness causes things to have huge potential to be cryptic. We build programs that are often comprehensible only to the author of those programs, and that can be a challenge when you're trying to work together. We often struggle. I don't know how many Forth-related repositories I've seen where there is a single committer, and I think part of it is maybe this is the nature of Forth, and we maybe sometimes don't actually desire projects at scale. It can be a problem if you've got too many people banging away on something. It's not necessarily a good thing, but for the purpose of this talk, I'm going to entertain the idea that this is something that needs to be fixed, and and there are some good reasons to do this, right? If you're I've now reached the age where if I go back and look at something I wrote a long time ago, it's a stranger that wrote it, and so I often discover like who wrote this? Oh, I did, and then and so you're having a conversation with yourself in time, and so the comprehensibility of your program over time is an issue. I also think that the fact that we're all here together suggests that we have some desire to connect with others and have Forth engaged in the wider world. So I'm going to focus on two different gaps. One of them is modularity and sort of ideas about how we can be more thoughtfully modular in our Forth programs, and kind of a related theme of data abstraction. And that one, the modularity one, I have sort of had more confident and clearer ideas. The data abstraction one, I'm going to sort of make a bit of sort of exploration, and then maybe make an appeal to you all to ponder and think about this domain a little. So modularity is all about being explicit about the interfaces between components and limiting how much you have to understand all at once. This is how you can scale a project up to a huge size. I work my day job. I work on code bases, sometimes into the millions of lines of code, and you have no hope of looking at every line in the program like that. You can only understand it in sort of isolated sections and hold only a portion of it in your head at a time. And so it's critical in that kind of a situation that you have an approach and a style that lets you limit how much of the program you have to comprehend at once. And this isn't an alien concept to Forth in general, right? Even in thinking Forth, there's this, but Forth extends the concept of modularity and information hiding further than any other contemporary language. Forth even hides the manner in which words are invoked and the way local arguments are passed. So there's sort of although there are some interesting things in thinking Forth, for example, about some of the negatives of sort of going too far in the direction of information hiding. I think it's certainly not an alien concept, but there is a sort of a question that I don't think has any universal consensus in the Forth community about how do you create a module? What is it if you want to engage in some amount of information hiding or sort of be explicit about your interfaces. What does that look like? One of the earliest and simplest that I found, there was actually this 3-line module system presented in some instance of the formal documents, and it literally is just the notion of, well, I'll have some internal words, some external words, and then the module. And so you use it something like this. If you've got, imagine the innards of a stack implementation. Let's say you're adding an alternate stack, and then you expose some interface, and this even works in a Forth. It assumes some things about the structure of your particular Forth, but this presupposes a Forth that doesn't even have vocabularies, and so you accumulate a few words that, and remember the point at which you had built up or the point at which the dictionary was at when you started the internal words, and then once you get to the external words, you sort of past the external words, you sort of clip off that section of the dictionary. You can do the same thing in sort of more contemporary style with vocabularies. It's actually there's a variety of different approaches to this. This is the one that the G-Forth documentation describes, where you sort of start off your vocabulary, sort of squirrel away some internal specifics in there, and then make reference to the external interface of it. This has the advantage because it's with vocabularies, there is a way to reach on into the insides if you're debugging and whatnot. But there's a problem with I think both of these. One is that internal words can't at least directly call external words in both of these. Now with vocabularies, and I'm going to explore sort of some ideas there. There are ways to make that work. And then more critically, both of these suffer from the problem that while you're sort of stuffing the unpleasant details off into the internal vocabulary or in the internal words, you're still sort of bleeding out into the global namespace all of the different all of the public parts of the interface. So if, for example, like with the stack, you wanted to use some of the internal words. Sorry, this is on that first point that the internals can't call externals. If you wanted to stuff, have a definition for P over, but and this is a contrived example, for whatever reason you didn't want to expose it externally, you'd have the problem that there isn't sort of a direct way. Now there's vocabularies, well actually for either of these, there's an indirect way you can do it. You can have the word be, have an internal, define it internally, use it down below, and then sort of create an alias for it on the outside. And that sort of works, but it goes in the direction of obscuring the fact that what you're really trying to do here is export some of these words, and now it's sort of mixed up. Where do I go look when I'm looking for, you've got multiple definitions for a word and things like that. If you're careful, and I mean, this is like inside of ESP32 Forth, I use this style a little bit where I'll sometimes have a word that otherwise would have been part of the external interface of the vocabulary, but I end up having to sort of have another name for it inside or alias to the outside. The second problem's even sort of more substantial, especially if you're imagining sort of scaling up interaction to a number of folks. If you had a component like your stack, and suppose that both foo and bar want to make use of that interface, but you want to hide that completely from main. You can do, there are patterns to do this with vocabularies, but they're sort of not particularly explicit, and they're not sort of there doesn't seem to be clear universal practice about how these are done. In preparing for this talk, I sort of thought, okay, well, let me have my crack at yet another sort of attempt at a module system. I used as a guide a contemporary language, Python, just because it's sort of thought of as having at least a relatively reasonable module system. And the main thing that it accomplishes is that it lets you do out of order exports. And then it actually has 2 word lists that are created per module, one for the internals of the word, the internals of the module, and then a second one for the exports. And that way you're not sort of having to pollute the outer vocabulary with the exports. And then but critically, when you import something, if you import it in multiple places, you still get the same module. So I don't mean to go through this in detail, but it's not that large. It's probably there are probably ways to make it terser and more efficient. And then what it lets you do is have a module like this, and you have the things that you want, and then you mark the items that you want to export from the module explicitly as exports. And then you, in other places where you want to use this module, you call import and import the particular things that you depend on, and you only import the things that you depend on, and everything else is sort of hidden from you. So you get basically, you know, the core Forth dictionary plus the things you explicitly import, and then, you know, multiple folks can import the same thing. And then at the very top, you do need to then actually use import the module system itself, and then that one import, you know, or several of them kick off a cascade of pulling in your transitive dependencies, and you'll only pull in each file once, you'll only compile it once, but you'll embed it, and that lets you do a thing. So I think that kind of thinking is sort of we need to find a way to standardize it or something, because at least the patterns that I've seen with vocabularies are very ad hoc. There isn't we group things into vocabularies, but we're really treating them more like a place to stuff the stuffing instead of sort of clear boundaries between both the imports and the exports. So now I'm going to pivot to talking about data abstraction. This section I have less confidence in sort of my conclusions here. So caveats on some of the things here. As I'll say at the end, I'm discontented with some of the places this went, but it's sort of an exploration because this is also an area where I'm unsatisfied. So some of you have seen some of my prior talks. I've made reference to the structured interpretation. I'm forgetting the name of it. Structured interpretation of computer programs or something. There's a textbook that is the sort of the intro, was the intro programming text at MIT, and they have a sort of an interesting sort of rubric for thinking about what makes a good programming language, which I find at least interesting. They're of course using it as a sales pitch for Lisp, but they basically say, well, what are the the three questions you want to ask about a language, or sort of what are its primitive expressions, what are the means of combination, and then what are the means of abstraction? And they and the notion is, it's basically what are the pieces you've got, how can you combine them, and then what can you do to give them names? And they kind of make a sort of a split down the middle of this, because they have the notion that, well, some of these primitive expressions and combinations and abstractions are about code, and some of them are about data. And I think that Forth does relatively well in terms of this particular rubric when you talk about code. We have a very nice patterns for the primitive expressions are these standalone words that do interesting things. The means of combination are just you glue them together one after the other, which is beautiful and sort of composable and nice. And similarly, abstraction is just you're defining words in terms of other words. But when it comes to data, we have operations that I think have some challenges that don't do so well with these properties. So one is, so with the means of combination, right, in conventional language, what this means is you've got some set of data types, you've got say structures and arrays, and you're able to make structures of arrays and arrays of structures, and in Forth you can do these things, but they're not sort of standardized. There isn't the one true structure system or object system that is universally used. And so it's sort of not idiomatic to the language. It isn't the default tool that everyone goes to. Arrays are, while you can sort of do what you want with memory, they're not really they're not typed, so there isn't really composability. There's you can compose the code that you use for it, but you have to sort of design for it. And then so fundamentally the problem is that you can define a lexicon that gives you strings. You can define a lexicon that gives you two of them, but it doesn't necessarily mean that they're composable. And same thing, even worse when it's sort of two types together. If it's a stack and a string, you can't sort of add them together and get a stack of strings. And the means of abstraction, like the main tool is create does, and it's it is not, I don't think there's quite as many gaps. I think most of the problems stem from that composition, the fact that you can't sort of readily combine data in a nice way that's sort of easy to reason about. Create does, I think, is all right. It mainly suffers from the problem that it's sort of single dispatch. So analogizing to like object-oriented languages or something, it's sort of you have one, you have a data object with a single method, which presents some challenges. So one way to address this is the various object-oriented lexicons that are out there. So Swoop, which I think Swoop is one of the I like Swoop as one of the nicer sort of wrappers that folks have produced over the years, and it tries to solve this in a relatively Forthy way. It's actually one of the more Forth. I think one thing I like about it is it's more Forthy than some of the other attempts at OO in Forth, but it still has this very if you use it extensively, your programs start to look an awful lot like you could have written them in Java. They're not. They lose the style that I think makes Forth nice. It's no longer something where you're just saying lush spin rinse spin, and the data flows outside of your view, and you're thinking of words as functions with parameters, and even if you haven't given them names, you're sort of thinking of them as parameters in a way that isn't normal for Forth. So you end up with this looks, in one sense, shockingly like a class definition in a conventional, third generation language, and I think the trouble is that it does provide for the possibility of, okay, you can build one of these and that works fine, and then you can stuff them in a value, but very soon what you're doing is now you're talking about named values, and you're needing, if you had one, say you created one of these points dynamically, now you have to pass that around and think about the type, even though you don't have a type stack, now you have to think about the parameters that are on that stack. Soon you're going to be tempted to use locals, and soon you've sort of devolved into a language where you would be better off naming the parameters and having stronger support in the language for sort of naming things. And I think the real problem is that in naturalistic Forth, like you don't, data isn't in the center, the words are in the center, the verbs are in the center, and the data just sort of flows around because of context. And the trouble with OO is that it tends to put the data front and center, and so it's important to give names to all the data. Everything, it's not just that you need to now name the types of the data. You need to realistically give them names for as they pass around, because they're kind of in the front of the stage. But I think that sort of naturalistically in Forth, what you would like to do is have words that sort of draw the data that they need from context, and then if you do need to generalize them, to change them from something that, say, works in one object to another, that you would do this through sort of changing the context around the word, so that you're not chasing down every single place that you refer to a word, and now you have to worry about changing all of your stack manipulation to pass an extra parameter. Because that's, passing an extra parameter is an easy thing in a language that sort of builds in named parameters, and you've already paid down the cost for it. It's an expensive thing in Forth that you have to say, oh, now this word has one more argument, and everybody that calls it, I have to go change it around. And I think there's a couple different progressions. So I think of generalization of from sort of one thing to many is there's sort of layers to it. So like there's singletons, words that sort of operate on the one thing, the state of the current block or something. And then there are situations where you sort of build up several. You might have additional stacks. Maybe you have a string stack, or you have an explicit stack, something like a graphics context, where you're kind of within the current transformation. Here's what I'm doing. You can name things, and I think all three of those first ones, and we'll talk about this in a second, I think those work smoothly. Where things get tricky is when you start having references, when you do something like open file or allocate, where it gives you back a handle, and now that handle is a typed thing. It's not just a number on the stack. It's not just an address on the stack. It's the address of a particular kind of thing that you need to worry about how you pass it around. So an explicit stack that works nicely, and I think that those right abstractions can work great, but that's a kind of a one-off abstraction. I build a string library and it has its own string stack and it knows how to manage the strings. Explicit stacks also, I think, work really well. In fact, so like, I mean, the example here is like, I've got a routine that draws a box, it crawls forward and rotate and sort of encapsulates the knowledge of how to make a box. And then if I later realize, oh, actually, I don't want to have a single notion of where the pen is, I will, I can now have a stack of pen states and save the pen state if I want to do something and then restore the old pen state. And this pattern is even in languages outside of Forth, like, this is how OpenGL works, where you have sort of layers of transforms, or JavaScript canvas contexts do the same thing, where you sort of you have a stack of contexts. And it's great because then you're not, now you don't have to pass your context to every, move to and box, and all of those don't have to pass around that parameter. You can name things and sort of if there's an implicit like target, that can work well for some things. Like if you're, sort of I call screen and now I draw to the screen, and I call printer and now I draw to the printer. But when you get to references, now you're going to pass it around on the stack, and you have to do things like remember when to release it. You have to, remember to close that file, or things of that sort. So as I was saying before, I think going from like a single object to a stack, or a single object to naming them where you sort of call them and then you can reference them, that works well. But going to references where now there's all the callers, that's a hard transition, because now if I previously had the word box and now I have to chase around every place I called box and everything built out of boxes and now pass an extra parameter to it because I need to pass one more thing, that's a problem. So how can we avoid this? One approach is to have the, sort of, if you had your implicit singleton, right, you can open one file and you can do something with it. Wouldn't it be nice if open file I didn't have to worry about the stuff that it returns, because every time I call open file, it's a pain. I'm having to sort of figure out the bookkeeping for it. I can stuff it in a constant, but that for this case that works fine. But okay, now I'm going to copy two files, and so it'd be nice if maybe naming is the thing, right? I could name where the file goes, and now I activate the file. And note here, I'm not in file and out file parameters. The ordering doesn't matter. I could have read complex data, could have tons of file operations that is this huge thing, and it's implicitly targeting in file the way that all of the number parsing and printing words reference base as you go down into it. So that naming could work. You could do a stack here, right? You could have, maybe there's some notion of I have a stack of files, and then each time I open a file, it pushes the stack and you read and write to it. And again, you get that nice property of I call in to read complex data, and even if it fans out into 1,000 different words, they're all dealing with one file, so I don't have to be passing the file down that hierarchy. So those are all sort of strategies. I don't know that I can package them up in some sort of good form, and I feel like there's something missing there. Generics, right? The idea of I want to take my stack and my string and now make a stack of strings. So I tried a thing. I called it parts, mainly just because it didn't clash with any of the built-in words. And the idea is to create a thing to make the kinds of abstractions I just talked about easier. So create well, what I call a part, or sort of a scope or a context-bearing thing. And then variables are defined in reference to that. It sounds a little bit like a record, and it sort of is, as you'll see, but it captures enough information so that you can now allocate multiple instances and keep track of which one is currently active. And so this is the innards of it. I'm not going to belabor that, but let's talk about what you could do with it. So you can define a singleton where you allocate one of them. And so then what happens is you say, okay, I have a part, which is a point, and X, Y, and Z here, right, are I'm defining them all in a shot. I've got a word tuple that defines them together. And then they're just like regular variables. I access them, I do things with them. It doesn't matter, sort of, whichever one is active is the one that's active. And if I have a singleton, that's it, right? This is just a roundabout way of declaring three variables. But if I name them, now I could say, well, I can have a point named Bob and a point named Joe. And if I activate Bob, now all of the things that refer to points reference the Bob point and then the Joe point. So that sort of progresses okay, and depending on what for a point, it's probably not useful to do that, but and then you can have a stack, and this is a little more complex, but you basically end up with a named stack, and then you have a way to push and pop to it. So you could say I want a 30-point stack and be able to push and pop to it, and all of the words in here can just directly refer to the sort of stuffing. And you'd presumably, of course, you've got variables named X, Y, and Z. You've got another problem, which is you need to go back and use modules, or else you're going to pollute sort of all the namespaces. And then you can do something, with this as a way of passing things around, and now you sort of got an easy way to define a stack. Now this lets you take any part and then define a stack from it, but stack had to, you'll notice stack was very specific and dealt down in the details. So one thing I'm a little unsatisfied with here is, would it be nice if stack itself were a part? And there is a way to do that. I can define a stack as a part, and then sort of have a helper word that does some of the extra setup, because I don't just want an uninitialized stack. I want the stack, and then I want to initialize the values in it, and then have a way to, and then all the other things work with this. And with this sort of a pattern, I can now take that same stack, and so stack is now a named thing, right? So just like I had Bob and Joe that were points, I can have a named stack for my points, and I can have a named stack for point stack, and I can have my name stack for some other data type or some other set of points, and I can switch back and forth between those. And so all the words that reference points can just reference points, and all the words that reference the stack can just reference the stack. So yeah, so that's what this is. But I'm still unsatisfied. I'm not sure, like, this is a thing, and it feels vaguely Forthy to me, but I'm also worried that the complexity could have crept up as this progressed. So that is the end of that. Are there questions, comments? As I say, I think the module things I feel more confident in. This discussion of how to compose data and what the right way to compose data is in Forth is a thing I think that troubles me and keeps me up at night. So
I would like to, as I'm watching this, I'm getting flashbacks of my previous conversations concerning aesthetic programming, because a lot of this I address in aesthetic programming, where I basically acquired a lot of the benefits of classical object-oriented programming, but without involving any frameworks or anything like that. It is all convention, and so you do need a certain amount of discipline to be able to use it. But at the same time, it's also very poorly documented. And I think if I could rehash some of the how can I say this? If I can rehash some of the concepts that go into aesthetic programming in the context of some of the things that you were not satisfied with, or some of the ideas that you had here, I think it might make for an interesting review, I guess, of the aesthetic programming concept.
Yeah, I definitely, I thought of some of your talks as I was preparing for this, and I did feel like there was a, here I tried to prescribe particular, here's this blah, blah of code, and here's a thing. But what I liked with the aesthetic programming is you were proposing a sort of a set of style practices and patterns. And I think to a degree, part of why this is a problem for Forth is because this sort of delves into areas that aren't well specified in the language and are a matter of conventions and practices. And I think there are some best practices that sort of slide out. And yeah, I think putting them into words and capturing them and finding sort of like names for the patterns and names for the approaches is so yes, I think that would be very interesting, because I do recall that many of these same things you kind of came at them with a slightly different angle, but it was this similar thing. You were sort of looking for patterns to make them composable and make them sort of, but not sort of lose that Forthiness at the same time.
All right. Thank you very much, Brad. Sam, you're on deck. It reminds me of a bygone era when I actually used to understand the computer that I've programmed. Log SIDS.